All right, for part B of this example, I'm going to do it a little more efficiently. I'm just going to list the terms and then look at the pattern and the results. So I'm given that A1 equals 1/2, so I can write that down to look at as part of my pattern. For A2, my n is 2, so n minus 1 is 1. That's A1 plus 1/2 to the 2. So I've just built the next term. And that's 1/2 plus 1/2 squared, or we've got the 1/2 and 1/4. It's 2/4 and 1/4 is 3/4. A3 is A2 plus 1/2 to the 3rd power. So n minus 1 is 2 here. I'm going to add 1/2 to the 3rd. That's, well, A2 is 3/4. And if I want to add 1/2 to the 3rd, 1/2 times 1/2 times 1/2 is an 1/8. So this is a 6/8 plus 1/8 is 7/8. And then A4, we're going to start to see the pattern after this. This is A3 plus 1/2 to the 4th now. I'm adding increasing powers of 1/2 to the previous term each time. A3 was 7/8, and this 1/2 to the 4th is 1/16. So if I think of this as 14/16, there's another 16, that's 15/16. And now let's look at the denominators here are getting recognizable as a sequence that you know. The doubling, 2, 4, 8, 16 powers of 2. 2 to the 1st, 2 squared, 2 cubed, 2 to the 4th, etc. Well, that's what the denominators are doing. So I would call, I was going to say my AN was downstairs, that's a 2 to the n, because we've got 2 to the 1st, 2 squared, 2 cubed, 2 fourths. So those powers of 2 follow along with the index. And then the numerators are just 1 less than each. So 15 is 1 less than 16, 7 is 1 less than 8, 3 is 1 less than 4, 1 is 1 less than 2. That's 2 to the n minus 1. So 2 to the 1st power is 2 minus 1, 1. 2 squared is 4, minus 1 is 3. 2 to the 3rd is 8, minus 1 is 7. And 2 to the 4th minus 1 is 15. There's another way we can write this formula, though. So this fraction we can write as 2 to the n over 2 to the n minus 1 over 2 to the n. And that is 1 minus 1 over 2 to the n. And that's going to be, okay, so this is a good way to write it. But this is going to be an even more useful way to write it when we study limits of expressions like this.